Okay, I can see you. Okay, thanks. I can see the classroom now. So let me start the today's lecture. So as I told you before, like for about 1 hour, we'll cover the theory part, and after covering that, I want there's a in-class assignment uploaded to the LMS. I'll show you when the time comes. So you need to do that assignment, which will be graded, and you have to submit it uh, before 3 p.m. Right? So before the class ends, so you have 2 hours to complete it. Right? So let me start today's presentation, the lecture. Right? So now we have covered all the basics almost. Right? So there are some useful operators that we can use when we develop certain Python applets, right? Rather than building everything up by yourself from the bottom, these operators can be useful, right? So the reason that I am explaining these separately, so these operators we cannot fit into certain group, right? It is not a data structure, it is not a loop or a statement, but it stands itself, right? Kind of a library, right? So let me explain some of those operators, useful operators that we will be using frequently when it comes to programming. Not all, but I want you to understand there are some basic stuff, and rest of the operators you need to find by yourself while doing your programming, right? So one very frequent and useful operators that we will be using is this range operator, right? So instead of uh, creating or generating list, right? Excuse me. Excuse me for 2 minutes, okay? I'll be back. Okay, sorry for the interruption. So as I told you, the range function will be useful, and we'll be using for various applications, right? So we can pass three parameters for a range function. What is the first one is the start and the stop and the step size, right? I will do some examples so you can understand this. So as an example here, the range, this will create a number list from 0 to 10, right? So that excluding factor is still there. So let me run this line. So if I run this one, right, it will create a range from 0 to 10, right? It is saved in the memory. So this is a generator function. So it will create these numbers and save it in the memory. But if we want to use it, as a useful generator or useful function, we can couple this one with the list function, right? So let me create a list using this range function. So this is my variable, right? So I'm creating a list and I'm using the range operator, right? So if I run this one, it will create that range and it will store that one inside the list that I'm creating, right? So note that, so starting from 0 and ending at 10, right? So do you remember that this same phenomena happens uh, when we were discussing the slicing in strings and lists, right? The same thing happens. So if we give a number, the stop number, it will give you the excluding that number, right? So if you need 11 here, so we have to have it like this. So list range, this is the starting point, 0 to 12, right? So the 12 will not be included, but the 11 will be included in this occasion. So if I run this one, it will create a list starting from 0 and ending from 11. So right, this excluding factor you need to remember, right? Uh, this is an important factor when it comes to Python operators, right? Where maybe sometimes for C or C++, this is not the matter. I think you may have understood that already. I think you have done those languages so far. So when it comes to Python, it's a different matter. So the n number is excluded from the list, right? So I told you we can give three arguments when it comes to range operator. So first one is the start, the second one is the end, obviously, and there can be a third parameter which is we call step size. So if we do not uh, indicate any kind of a uh, argument as the third parameter, it will, as a default, it will consider it as one, right? But of course, for different applications or different requirements, you need to have a step size. So as an example, let me show you an example. So this is the starting. So still we are using the range function and we are preparing a list out of it, right? So it's starting from 0 and it's ending from 10. Mind that 11 is not included. So starting from 0, ending from 10, and the step size is 3. So let me run the cell and show you what happens. So run. So it says 0 is there, of course. Instead of 1, now we have indicated or given an argument to retrieve the step, to activate the step size. So step size is 3, so 0 is there, and 0, 1, 2, 3. The next output is actually 3, right? And after 3, we have another 3 steps. So 1, 2, 3, 6 is there. Likewise, 9 is also there. So the step size also you can indicate or you can uh, provide as an argument for this range operator, right? So let me show you another example. This one is starting from 20, ending from 101 means 100, and the step size is 5. This is a quite a big list. You can see. So every number after every 5 steps will be indicated here until it's 100, right? So this range function is not that difficult to understand, and also it's very common operator that you will be using uh, when you are writing Python codes, right? uh, these are actually not libraries but some helping operators that you can use, right? These are there any questions regarding this? I think this is very straightforward and simple operator, the range one. So you can ask via the chat box if you have any questions regarding this. Right. So another announcement is that I have uploaded the lecture notes that we have done so far to the LM, right? So you can download these lecture notes as PDFs, and you can test these simple OD snippets and check the things that we have learned. Okay, so please check the LMS as well, right? So no questions from this, right? Okay, let me move to the next part. So enumerate, right? This is a enumerate operation. So what is enumeration, right? So let me show the meaning of enumeration uh, with an example. So this enumerate operation is very useful when it comes to loops, right? So you can couple with you can get enumeration function, the total advantage of this enumerate operation when it couples with loop, right? So let me show you an example. So here in this specific example, you see that we will be initiating something called index count, right? So index count is initialized because we need to understand how many letters are there and how these letters are indexed. So the purpose of this snippet is to understand what is the index of A and what is the index of B and what is the index of C. Likewise, to understand the index and the respective letter. That is what it will do. So there's a variable defined, and we will be counting that variable up when we go through uh, the string that we have shown here. So this part, I think the for loop, this example we did last week. I think rather week, right? Last week was a holiday. So week before that we did this example. So I hope that you can remember these things. So if I run this one, let me run this cell, and it will show you the index and the letter, the corresponding letter. So that is there. The second, the next index also there, and its corresponding letter is also there. So we have to have a separate variable to understand how many loops that we are going through, or how many loops that we are counting up. So that is the normal practice, right? In other programming languages also, that is the normal practice. But uh, to count the number of operations in a loop, or simply arrange these what do you call indexing, we can use this enumerate operation. So let me show you how it happens. So for so we are giving, instead of one argument, we are giving two. So first one is the index, second one is the letter or number or anything that we are feeding, right? So then we enumerate. So this is a keyword. We are enumerating the string, right? So this I will be automatically count as the index, right? And this letter will be automatically mapped to the letter that we are feeding, like A, B, C, D, E, likewise, right? And this is a printing function. So we will be mapping each letter. So letter comes here. So sorry, index comes here, letter comes here, and it will be automatically mapped to I and the letter, right? So can you see the difference? Here we are using a separate variable to store the index, right? But here we are directly using this enumerate operation. So if I run this one, let me run this out. See, so the automatically it will map the index, this index with the corresponding string, right? So this can be anything, right? So we can enumerate a list, we can enumerate a tuple, we can enumerate a string. So depends on our requirement, you can modify this one, right? So something like similar to tuple unpacking. We discussed this one uh, previous to this lecture as well, right? Tuple unpacking means we are separating because tuples are immutable. We cannot modify or add or do and cannot do anything. So if we want to do some modification to a tuple, what we have to do is we have to extract or we have to unpack the tuple and work with it. So we discussed those things previously, right? So any questions about this enumeration? It's also fairly straightforward thing, not difficult to understand, I think. But it's you have to uh, you have to know that these options are available when you are working with Python, right? Any questions you can ask? Okay. Okay. So hopefully there are no questions on this. So now we discussed two operators. One is range and the other one is enumerate. And let me introduce another one. This one called zip, right? So zip means simply uh, okay, right? So zip means as the name stand itself, you can connect uh, two lists, right? Right. So as the name stands, so we can zip or we can connect to uh, list or a tuple uh, according to our requirements, right? So one thing you can do is you can use a loop, right? So instead of loop, we can directly use this zip function to connect or to generate uh, adding two lists, addition of two lists, right? So as an example, so here it says my list and the list is there, this my list one, right? And the second one is my list two and there are some strings. So we can create a zip using these two lists, right? So let me run this one. And if you do not indicate where to show these zip files, because this is an generator, do you remember? I think you remember that previously also, if you run only this line, it will save the output to a memory location, right? So we have to get that output to a list. So if I run this one only, so it will show that the list is created, but it is saved in this specific memory location, right? That is what it will give as an output. So we have to cast it or we have to save this specific output to a list, right? If I run this line, now we are saving the output of this SIP operation to a list. If I run this one, see, it will create a tuple pair, right? So the specific first index element, and it will SIP that, or map it to the first index of the other list. Likewise, it will create a tuple pair like this, right? So note that even though in the first list we have 7 uh, elements inside, but we have only 4 elements in the second list, so it will choose the less number of elements which is available inside the list and map according to that, right? So the same thing. So somebody may ask, what is the application of this? But we can use this same application with a for loop, right? So see, we are creating a for loop using this list 1 and list 2, and we can show the output by mapping each other like this. So there are some applications uh, that you may need to use these kind of operations, right? So the SIP operation is simple operation which you can map two lists or two what do you call tuples and create a single tuple pair, right? So this can be done using the SIP operation. So any questions from this part? This one is also quite straightforward. Any questions or concerns? So I'm just going through this different kind of Python operations, and okay, let me go to the next one. So in operation, right? So we have used this in keyword already with loops, right? So it indicates that we will be using this source, this specific source, and we will be looping through it. So that is the meaning of this in keyword. But other than that, there's another advantage as well. So we can check if some it is similar to this Excel file, right? So you can find whether a certain element is in a certain column or a certain row. The same thing can be done in Python programming as well. So we are checking whether this character is available inside this specific list, right? So this will output as a boolean, right? So without running it, actually X is available inside this list, right? So if I run this one, the output will be true. Of course, X is available there. And if I try this one, this is 1 2 3 in the list. There's no X inside this specific list. If I run this one, it will put that as a false, right? So not only for list, but also you can do this for other data types as well, right? So this dictionary, uh, you may remember it has key and value pair, right? So we can check whether these keys are available inside this dictionary. So as an example, so we are checking here whether the key 2 is in this specific dictionary. So we can run this cell and see. So yeah, it is true. Of course, it is not available there. But if we try a different key, say key 3 in D, it may return false, right? So this is also a straightforward operation. So you don't have to write several lines of code to check whether an element is available inside a list or a tuple or a dictionary, right? So that is also a straightforward operation. Okay, so just similarly, so we are checking whether it's in there. So we can also check whether it is not in there, right? This is also a kind of straightforward operation. So we are checking the negative output. So X not in this list, but actually X is in this list. So this will return, what do you think? True or false? What would this function would return? Yes.
False.
Yeah, this will return false, right? So this will return false like this, because actually X is in there. So not in there means false. So this one also the same. X is not in there. Of course it is true. So this will output as the true. Right? Similarly, you can try with the other data types as well. So this one, key 3 is not in D. Of course it is not in D. So it is true. Right? This one is output will be false. Right? So I think you may remember we can access to dictionary values using this notation, right? So we can one by one check the values inside the dictionary as well using this syntax. So we can check whether this 100, that means the value. So this is a key, this is a value, this is the key value pair, whether these values are available inside this specific dictionary, right? So if you run this one, 100 not in D dot values, that means this is false because 100 is available in there, right? So this is in and not in operations. You can select different sorry, you can select different kind of uh, data structures and you can work with this uh, operations, right? So this is also fairly straightforward. You can ask me if you have any questions, so I will go to the next one as well. So we can deal with min max as well, right? So as an example, without writing several lines of codes, as I explained before, you can directly, these libraries are already in Python, so you don't have to worry about it. So as an example, this my list, it has several numbers. So without creating a for loop and checking what is the largest number there, you can directly let me run this one, and you can directly select the minimum value. So that is very convenient when it comes to MATLAB, right? So maximum value also there. You can directly select the maximum value from a list or a tuple, right? Using this operation, right? I think this also fairly straightforward one. Just using these operators, min max values, right? Okay. Then there's a library called random, right? It's a fairly big library. There are a lot of applications, I mean users are there. So say that if you have created a kind of a program, right? So you need to provide data and see whether your program works, whether the outputs match with the input, right? So rather than feeding data one by one, so you can use this random function to feed random integers or floats, or there's something called Gaussian, those things you can feed using this random function. So random has a lot of uh, applications, lot of methods, right? So here, for this specific example, I'm using what you call shuffle function, right? So it's, what shuffle function do it is randomly shuffle the elements that we feed to this, right? So now remember, this my list has 10, 20, 30, 40, 100. So we can randomly shuffle that one. uh, but before that, you have to import this library. So that is what I have done this in this first line, from random library. So this library, so we are using importing shuffle function, right? So this is what we will be doing. So what we are going to do is, then we have to feed what is the thing that we are shuffling, right? So shuffle, this is the function, and it will shuffle the list, right? If I run this one, sorry, I have to import this first, and if I run this one, you can see, so it is shuffled, right? Okay. Okay, so if you run this one again and again, so it will shuffle differently. Can you see it? So now it's 20, 40, 100. So if I run this one again, arrangement will change. So it's, the shuffling is random, so there's no specific uh, what do you call it? Specific arrangement for that shuffling, right? So there's another function called rad int. So in this specific function, this is inside the random library as well. So you can get random integers, right? So you have to provide what is the low and high range, right, for this random integer, right? So Okay, sorry for the interruption. So as I told you, from these random integers, you can obtain from random operation, right? So if you run this one, so it will give you a random integer output from that brain, right? Every time you run, see, it will give a different output, right? So this is okay, this is actually repeated. So this is what these random functions would do. So there are a lot of functions belongs to this random what do you call random library. So please check by yourself. There's very good kind of a user manual, user support documentation for Python. So you can check with that as well, right? So this is also, I think, fairly straightforward. So let me move to the next one. So this is inputs, right? So say that in any kind of a program, you may require to get the user input, right? So this user input can be obtained using this input keyword, right? So this is a variable that I have assigned. So this is the text that will show in the command line, and we will get the input from this uh, command line, and it will be assigned to the variable here. So that is the syntax, right? So variable, and you are getting the input, and you are assigning that input to this variable. So because Python variables are dynamic, as we discussed earlier, so you don't have to define what kind of a input variable that you will have to use. So that is a advantage when it comes to Python, right? Okay, so let me run this one. So this cell. So if I run this cell, so it will show they enter something into this box, right? It can be anything, right? So hello. So this is a string, right? Then I enter. So this will be registered as hello, right? So let me check the user input now. See, it says hello, right? And you can provide the integer as well. So this is an integer. So if I run, if I check, so you will get the integer value of it, right? So the thing that you need to understand, so please listen carefully. All the inputs that we uh, send to or we register will save as a string, right? So initially it will save as a string. So if you need to save it as another data type, right? So if I check this one type, so still this is one, right? It one means what we think as integer. But see, this type is actually a string, even though it is one, because the input will be saved as a string if we do not uh, define what kind of input to expect, right? So that can be done by adding this data type, the expected data type. You can have it or not. It depends on your application and your requirement, right? So if you want to accept floats, so you can define float here and then the input, right? So any input that is not a float will not be accepted. So if I run this one, so if I select 12.5, yeah, it's a float and no errors occurs, right? Sorry, no errors occurs. Say we have entered 10, okay? Of course 10 is an integer, but it can be mapped as a float as well, right? So if I check now, so it gives 10.0, mind that, not 10, 10.0. So it will convert it to a float and show it to you. So what will happen if I enter a letter? Say hello. Previously it accepted, right? Previously in this command line it accepted this hello. But if I run this one, will it accept? Uh, Something happened. Now it's still running. See, so it's an error. It will not accept this one because it is not a type that it is expecting, right? So if I run this one and see, it will not give you an output specifically. It will give an error, right? So likewise, you need to give the specific data type if you are mentioning what kind of data that you will be expecting, right? So any number will be, of course, fine. No problems will occur. Right? Right. And also, after you have input some kind of a value or some kind of a variable, so you can directly do any type of a modification or calculation directly to that variable, right? So that is also there. So as an example, so this integer number now it's 12, so I can directly add a number to there like 30, doesn't matter. So directly those operations can also be done. So that advantage is also there, right? So those are the basic operations that you can come across with Python programming, right? So any questions or concerns regarding these operators? You can ask if you have any concerns. We discussed several Python operations. There are many more, but we don't have time to go and discuss one by one of these operators. So simply we don't have time. That much of operations are there, right? Okay, so all right. So if you do not have any questions, so I'll conclude the lecture here. So now I'll show you where you can find this assignment, right? So please go to the LMS, right? So in the LMS, you can see I have updated the lectures that we have done so far in PDF format, right? So you can run these Python codes in Jupyter environment and see what are the outputs, and everything is there, right? Until the today's lecture, right? So I will upload the today's part to the LMS as well, right? In here, so you have this assignment, right? Please go there, right? In the assignment, uh, you have this document, assignment document, right? So please download it. Please download the assignment document and do your assignment on the assignment. I mean, this document itself, right? This is a Word file, so you can modify. You just have to copy paste the codes and the answers from the Jupyter notebook environment, right? And you need to submit it within 2 days, right? I have given until 3 p.m. So it will take about maybe one and a half hours. So please complete it and submit it. Okay. So this is regarding the objects and data structures that we discussed few weeks ago. So any questions about the assignment? I will be marking this one, so please do it in proper manner. Okay. Okay. So the LMS window is open now until 3 p.m. Please complete this one and submit it. Okay, you can ask any questions if you have. Okay, so the assignment looks like this. Okay, so you and I am, and please write the answers on the page itself. And there are some codes that you have to write down. So in the given space, please write down those codes or type it down the codes. Right. So there are several questions corresponds to each uh, data type, and a small part about statement as well, right? The things that we did today. So not that difficult, but last part is not that easy as well. So try and please submit within today, right? Before 3 p.m. please try to do it things by yourself. Okay, so if you copy paste some other person's code, it's fairly easy to understand, right? So don't copy paste, just try by yourself so you can understand your level as well.